There may be a planet in the solar system we've never seen. Massive, distant, hidden somewhere beyond Neptune, in the darkness at the edge of the sun's reach. We can't photograph it, can't observe it directly, can't point a telescope at it. But the math keeps pointing to something out there. Because at the edge of the solar system, something is wrong. Objects are orbiting in patterns that shouldn't exist, clustered, tilted, aligned in ways that gravity alone can't explain. Unless something massive is pulling them, shepherding these distant objects into impossible orbits. The evidence is mounting. There may be a planet, and we're hunting for it. Tonight, we're following the search for Planet 9, the hidden world that might be lurking at the edge of everything we know. Let's begin. Beyond Neptune, there are worlds. Small worlds, dwarf planets, chunks of ice and rock orbiting in the outer darkness. Most of them stay close, in the Kuiper Belt, the region just beyond Neptune, where Pluto orbits. But some of them don't. Some of them have orbits so extreme, so elongated, that they swing far out into the void, thousands of times farther from the sun than Earth. Out where the sun is just a bright star, where it takes centuries, millennia, to complete a single orbit. These are the extreme trans-Neptunian objects, the distant ones, and they shouldn't exist. Not the way they do. When astronomers started mapping their orbits, they found something impossible. The orbits were aligned, not scattered randomly across the sky, which is what you'd expect, but clustered, pointing in the same direction, as if something was organizing them. And their orbits were tilted relative to the plane of the solar system, pulled out of alignment, warped. This doesn't happen naturally. In a solar system with only the known planets, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, these orbits should be random. But they weren't. They were grouped, shepherded, as if something massive, something invisible, was pulling on them. And the odds of this happening by chance? They calculated it. Less than 1 in 15,000. That's their calculation, and it depends on how complete our census really is. Something was out there. Something we'd never seen. In 2016, 2 astronomers published a paper, Konstantin Batygin and Mike Brown. They'd been running simulations, testing models, trying to explain the strange orbits at the edge of the solar system. And they found the answer. A planet. Not a small one, a massive planet, 5 to 10 times the mass of Earth. A super-Earth, possibly edging into Mini-Neptune territory, orbiting on a long, elongated path far beyond Neptune. Its gravity would explain everything. The clustering, the tilting, the alignment, all of it. If the planet was there, If it existed, it would shepherd the distant objects, bend their orbits, pull them into the patterns we were seeing. The simulations worked. So they gave the hypothesis a name: Planet 9. In 2021, Brown and Batigan refined the likely range, a mass closer to 5 to 8 times Earth's, a super-Earth, and a search region somewhere between 300 and 520 astronomical units from the Sun, roughly 28 to 48 billion miles. The evidence was indirect, circumstantial, but compelling. Like discovering a black hole. You can't see it directly, but you can see what it does, the orbits it warps, the stars it pulls. Planet 9 was the same. Invisible, but powerful enough to leave fingerprints in the dark. And if it was real, it had been out there the whole time. Since the solar system formed, since before humans existed, since before life, orbiting in the darkness, alone, unseen. A hidden world in our own backyard. Right now, in Chile, a telescope is watching the sky change. The Vera C. Rubin Observatory. First images in 2025. The survey is ramping up now. And it's built to detect motion, transient events, objects that shift over time. Simulations suggest Rubin could discover tens of thousands of new trans-Neptunian objects over the coming years. Many times more than we've ever catalogued. Far more data. Enough to test whether the clustering is real or an illusion created by limited data. Rubin may not give us an instant answer. It won't point to a specific coordinate and say, there. But it could finally tell us whether the outer solar system is being shepherded by something massive, or whether we've been misreading the pattern all along. Multiple teams are watching, waiting. The Subaru telescope in Hawaii continues its deep imaging surveys. Sky surveys compare images taken months apart, looking for faint points of light that moved. All of them searching for the same thing. A faint point of light, moving slowly against the stars. Because that's all Planet 9 would be. A faint point. At 300 to 500 times the distance from Earth to the Sun, maybe farther, it would be receiving almost no sunlight, just a tiny fraction, and the light it reflects back would be incredibly faint, around magnitude 22, maybe 24, depending on where it is and how reflective it is. Far too dim to see with the naked eye, far too dim for most telescopes. You'd need a large telescope, a very sensitive camera, and patience. Because Planet 9 isn't just faint, it's moving. So slowly you'd miss it in a single image. But with repeat visits, its motion, mostly from parallax, can reveal itself. You'd need to image the same patch of sky multiple times, compare the images, look for something that shifted, a point of light that moved. But the sky is full of faint points of light. Stars, galaxies, asteroids, millions of them. Most aren't moving, or they're moving in predictable ways. Planet 9 would be different. It would be moving slowly, in a direction you wouldn't expect, in a region of sky you'd have to guess. and the search area is enormous. Thousands of square degrees, a huge swathe of the sky. Somewhere in that region, maybe, is a planet. And astronomers are scanning, image by image, night by night, hoping to find it. But here's the thing, they might never find it. Not because it's not there, but because it's too far, too faint, too hidden. Sometimes the answer is hiding in old data. In 2025, researchers went back to archives from decades-old infrared sky surveys, catalogs that mapped heat signatures across the entire sky, looking for faint, cold objects. IRIS in 1983, Akari in 2006. 23 years apart. Both scanned the entire sky. Both catalogued faint infrared sources. And when they compared the two datasets, they found something. A candidate source. Faint, unidentified. And it appeared to shift. About 47 arc minutes in 23 years. The kind of slow drift you might expect from something extremely distant. It's not proof. It could be noise, a data artifact, a background galaxy misidentified. But it's a coordinate, a shadow in old data. Something follow-up telescopes can now test. A possible location for Planet 9. Or nothing at all. If Planet 9 exists, it wasn't always out there. Planets don't form that far from the sun. There's not enough material, not enough gas and dust. So if Planet 9 is real, it formed closer, probably near where Jupiter and Saturn are now, in the inner solar system, where the other planets formed, where it belonged. And then, it was thrown out, ejected. A gravitational encounter with one of the giant planets, Jupiter or Saturn, a close pass. Planet 9 came too close, and the gravity, overwhelming, violent, flung it outward, catastrophically, thrown to the very edge of the solar system, to a distance where the sun's gravity barely holds. This happened early, when the solar system was young, when the planets were still migrating, colliding, settling. Planet 9 never got to settle. It was cast out, exiled before the solar system even finished forming, and it almost escaped entirely, almost broke free of the sun's gravity and drifted into interstellar space. But it didn't. It stayed. Barely. Captured in a distant, elongated orbit, bound to the sun by the thinnest thread of gravity. And it's been out there ever since. Alone. Orbiting slowly. Taking tens of thousands of years, maybe more, to complete a single orbit. While everything else in the solar system moved on, while the giant planets settled into stable orbits, while Earth coalesced from dust and rock, while life appeared in the oceans. Planet 9 was already out there in the darkness. While humans appeared and looked up at the stars, Planet 9 kept orbiting, silent, unseen, forgotten. If it exists, it's a member of the solar system. Technically, gravitationally bound to the sun, part of our system, but it's not part of our world. The inner planets, Mercury, Venus, Earth, Mars, orbit close to the Sun, warm, visible, and known. The outer planets, Jupiter, Saturn, Uranus, Neptune, orbit farther, but still within reach, still observable, still part of the family. Planet 9 is different. It's so far that it doesn't belong to the inner solar system, doesn't interact with the planets, doesn't participate in the dynamics of the system it was born into. It's an exile, a world that was cast out before it had a chance to exist alongside the others. And the brutal truth is this: Planet 9 will never return. Its orbit is stable. It will keep circling the Sun at that enormous distance for billions of years. A world that's part of the family, but forever on the outside. Forgotten. Cast out. Out where Planet 9 might be, the Sun is just a star. Not the bright disk that lights the day, not the warmth on your face. A point of light. Still the brightest in the sky, but too weak to warm anything. At 300 to 500 times the distance from Earth to the Sun, sunlight is hundreds of thousands of times weaker. Enough to be a pale, cold glow. Shadows would be faint. If you could somehow stand on Planet 9, you'd see the Sun as a distant, cold star. And around you, darkness. No other planets visible, no moons, no structure. Just stars, scattered across the void, faint, distant, indifferent. You'd be farther from the Sun than anything we've ever reached. Farther than Voyager has traveled. Farther than the Kuiper Belt. Farther than the scattered disk. You'd be approaching the Oort cloud, the shell of forgotten objects at the edge of the Sun's gravity. But Planet 9 isn't like the Oort cloud objects. The Oort cloud is a graveyard. Trillions of small, frozen fragments, scattered, anonymous. Planet 9 is different. It's a world, a planet, massive enough to be round, massive enough to have gravity, massive enough to matter, but singular, more alone than anything else in the solar system, because at least the Oort cloud objects have each other, scattered through a shell, part of a structure. Planet 9 is singular. One world, cut off from everything, orbiting in isolation. The temperature would be a few degrees above absolute zero. Colder than anything in the inner solar system. Colder than Pluto. Colder than the outer moons of Neptune. If Planet 9 is rocky, its surface would be frozen solid. No atmosphere, no weather, no geological activity. Just ice and rock. Silent. Dead. If it's an ice giant, a smaller version of Neptune or Uranus, it might have an atmosphere. Hydrogen, helium, methane. But frozen, dormant, dark. No storms raging across its surface. No great red spot. No bands of clouds. No lightning. Just a cold, dim sphere, reflecting almost no light. Invisible. And if it exists, It's been like this for billions of years, orbiting in silence, while the inner solar system, everything within a few billion kilometers of the sun, was full of light, warmth, motion, life. Planet 9 was in the darkness. Here's why we can't find it. Planet 9, if it exists, may be near aphelion right now, the farthest point in its orbit, which means it's as far from the sun as it can be, and as dim as it can be. At that distance, it would be one of the faintest objects in the solar system. And it's moving slowly, very slowly. To detect it, you'd need to image the same region of sky multiple times over months or years. Compare the images. Look for a faint point that shifted. But the search area is huge, thousands of square degrees, and most sky surveys aren't deep enough to detect something that faint. You'd need a large telescope, a long exposure, and you'd need to be looking at exactly the right patch of sky. And even then, you might miss it, because Planet 9 might be behind the Milky Way, hidden in the dense star fields, invisible against the background. Or it might be in a region that hasn't been surveyed yet. Perhaps it's farther than predicted, dimmer, smaller. The solar system is vast. Planet 9 might simply be too far, and far too faint. We could search for decades and come up empty, because the universe doesn't owe us easy answers. Planet 9 could be out there right now, orbiting silently, and we might never see it. And there's another possibility. Planet 9 might not exist. The evidence is compelling, but it's not definitive. In 2025, astronomers confirmed a new extreme trans-Neptunian object, 2023 KQ-14, nicknamed Ammonite. It's a sednoid, a world with a highly eccentric orbit, just like the objects that originally suggested Planet 9. But Ammonite doesn't follow the pattern. Its orbit isn't aligned with the others. It's tilted differently, clustered differently. One object, and it complicates everything. Some researchers argue this makes a single planet explanation less clean. That if Planet 9 exists, it may need to be farther out than many predictions suggest, or that the outer solar system is simply more complex and varied than we thought. The clustering of the other distant objects is real, but maybe it's a coincidence. Maybe we haven't discovered enough objects yet to know if the pattern holds. Maybe it's observational bias. Maybe we're more likely to find objects in certain regions of the sky, creating the illusion of clustering. Or maybe there's another explanation. Some astronomers have suggested a primordial black hole, a tiny black hole left over from the early universe, wandering through the outer solar system. Others suggest a disk of debris, a massive ring of objects beyond Neptune, gravitationally influencing the distant worlds. All of these are possible. But the simplest explanation, the one that fits the most data, is a planet. A massive, distant planet, orbiting in the darkness. And until we find it, or prove it doesn't exist, Planet 9 remains a ghost, a mathematical prediction, a shadow in the data. And even if we find it, even if we photograph it and confirm it exists, we'll never reach it. At Voyager speeds, the journey would span centuries, lifetimes. We might photograph it, study its orbit, measure its mass, but we'll never touch it. There may be a planet in the solar system we've never seen, not in another galaxy, not light years away. Here, in our solar system, orbiting our sun. And we don't know if it exists. We've mapped distant galaxies. We've photographed black holes billions of light years away. We've found thousands of planets orbiting other stars. But we can't answer a simple question. How many planets orbit our own sun? 8 or 9? We're looking for it right now. Telescopes scanning the sky, night by night, image by image, looking for a faint point of light that moved. We might find it tomorrow, or never. The search could end with a discovery, a coordinate, a photograph, proof that Planet 9 exists, that it's been there all along. Or it could end with nothing. Just the slow realization that the math was wrong, that there's nothing out there after all. And we'll never know which it is until we know. But we do know this. At the edge of the solar system, hidden somewhere beyond Neptune, in the darkness at the edge of the sun's reach, something is wrong. Objects are orbiting in patterns that shouldn't exist, clustered, tilted, aligned in ways that gravity alone can't explain. Unless something massive is pulling them. A planet orbiting in the darkness, silent, invisible, waiting to be found.